Here we have a few splines that we'll be using as our rails. The character can lean into curves, rotate around the spline, and follow loops. While the content of the video is focused on moving along the spline, not making its blueprint, you can download the blueprint that I'm using from the description and follow along for this video. You can also check out the making of this blueprint in my previous videos as well if you want to know more about splines and spline meshes. Otherwise, let's just get into it. So I'm going to go in and place our spline in our level. And I'm going to be using the pipe mesh that comes with the starter content. And that'll be good for now. Then we're going to open up our third-person character. And I'm just going to scroll up to the top, and we're going to create a custom event that's going to be handling our trace. So, custom event, and we're going to call it Spline Trace. And this is what we're going to be doing to have our character get an overlap with our spline. This is something that I'm only going to want to do if we are actually falling. And so what we're going to do is get the character's movement. And then we are going to get velocity. We're going to split the pin. And we're going to say if the Z value is less than 0, then we continue on with true. And we're going to get a sphere trace by channel. And our start and end location, we kind of want to have this be a sphere by our feet. So the start and end location of the sphere is basically going to be the same, which is going to be our actor's location minus 80 to 100. So get actor location, subtract, we'll just say 80. And that's going to be our start and our end. And our radius is going to be, we'll say 40. So we're going to get event tick. This is something that I'm going to want to move over to a timer, but I will in just a second. We're just going to do spline trace. And I'm going to switch to the play in window. And it would help if I had the debug going. There we go. So as you'll notice, I'm falling onto the spline, but there is no collision that is being triggered because we are going to have to do several things to be able to get any information off of our spline. Firstly, we want to make a new trace channel. So we go to Edit, Project Settings, over in Engine, Collision, New Trace Channel, and we're going to just call it Rail. And we want to set it to Ignore by default, and Accept. Then we want to open up our spline blueprint, and on our Add Spline Mesh component, we want to go to where our collision is. Change it from, well, it's actually already on custom. We just want visibility rail changed to block. Compile it, save it, then we can close that blueprint. And we want to change our sphere trace from visible to rail. And if that's not showing up, you'll just have to compile it and save it again. So now that we have the trace channel set up, you can see that it is actually hitting this now. So now for the next part, we want to go down to our event begin play, and at the end, we want to get all actors of class. And change the actor class to our BP splines. We want to promote the out actors to a variable, and we'll rename it rails. So this is going to be everything that we're going to be using as a grind rail in our level. The reason why we do this is because overlapping it and getting our out hit isn't going to be enough. We need to make sure that what we're actually colliding with is going to be of the type BP splines here. Because if we break the out hit and we save a variable of the hit actor, it's just going to be of type actor, and then we can't get any variables off of it. So we can keep that break hit result, and we're going to make a branch. And we're going to drag in our rails, and we're going to get a for loop for each. Then we can promote this to a variable, and this is going to be our grind rail. So I'm going to name it as such. But what I want to do first is make sure that this array element is matching the hit actor. So we can drag out the array element and type in equals twice and connect the hit actor here. We are going to get another branch. And if it is true, then we are going to connect our grind rail and set that as a variable. And so just to test that, we're going to get a print. And just print the string. So when we overlap, we can see that it's generating Beeply splines. We're going to change our movement mode, because once we get onto the spline, we don't want to be moving normally anymore. So I like to just get stop movement immediately before we do anything. And then off the character movements, we're also going to set the movement mode. And keep that at none. And now I'm also going to take this time to get this off of our event tick and onto a timer. So just off to the left, I'm going to create a new custom event. And I'm going to call it start trace. And we're going to set timer by event. In the event, we're just going to create event. And we could set that to be our spline trace. I'm going to take the return value and promote that to a variable and rename it as trace timer. And because we only want this to be firing off once, I'm just going to put a branch and connect it to false. So we will take our trace timer and then get is timer active by handle. So if it isn't, then it will start it. And if it is, we won't be doubling up on timers. And I also want an event to call at any time to be able to stop this trace. So I'm going to make another custom event. And it's just going to call stop trace. And we are going to clear and invalidate timer by handle. That's going to be our trace timer. So I'm going to remove the event tick and our spline trace here. And I am just going to start the trace anytime we jump. So I'm going to go down to our input action for jump, and right after jump, we are going to call our start trace. And once we get this far, we want to stop because we are already going to be making contact, so we can just call stop trace here. We can also call stop trace after we declare a variable. It doesn't really matter where it goes in the chain here. And because now we are on the spline, I'm going to make a variable that's going to be a Boolean, and we're just going to call it on spline. Drag that in and set that to true. And we're going to use this to change our animation from our normal idle animation to the Mixamo animation. And then before we test this, we want to go back to our timer, and we're going to change the time to 0.001 and set it on looping. Now we can compile and save, and then we should see this trace start to happen. And perfect. Now we are going to make a function to determine how we move down the spline. So we can go to our functions and click add, and we're going to call it find spline distance at overlap. We're going to have two inputs, one of which is going to be our location of type vector. Another one is going to be our spline of type BP underscore splines and get the object reference. And our output is going to be a float, which is going to be our distance. Okay, and I'm just going to go back to our event graph real quick, and I'm going to drag our function in, place it here. Our spline is going to be our grind rail. So we can connect that in our location. If you want to set it as a variable, you can. It's going to be the impact point, or you can just drag it over lengthwise like how I'm doing, because we're only going to be calling this once and this can kind of be condensed. Just a matter of preference on your end. And then we're going to go back in here and we're going to go through setting up how to find the distance on our spline. So really simple, we're going to drag in off of our spline and we are going to get spline. And there is a built-in node for this. It is find input key closest to world location. Now, when we have our spline points, really what they're called is input keys. If you have 5 points, you have 5 keys. These are represented in a float value of 0 through however many points you have minus 1. And the distance between the two, it has a float value. So we need to take that float value and turn it into actual distance that's going to be usable for us in a function. We can connect the location to our world location here. And so we need to drag off of our spline again, and we need to get distance along spline at spline point. And then we can copy it or duplicate it, because we're going to need to do that again. So if we land between 2 points, we need to get the distance of the point before us and the point after us. So we can take this value and then we can truncate it. Truncating just rounds it down. So if we land at a distance of 3.5, it just counts it as 3. And that's going to be our first. The next one, we're also going to truncate, but then we're going to add 1 to it. That way, if we land at 3.5, we get 4. Now we want to get the distance down our current spline point. So we can take this truncated value and we want to subtract, actually lower this to the second pin, our input key. So now if we were 3.5, now we're just getting 0.5. Then we want to take our input key here and subtract it from this key. So now we only have the length of our current key. Then we are going to multiply it by our value below. And then finally, we want to add what we already stripped away. Okay, now we can go back to our event graph, and we're going to take this distance and promote it to a variable. And we're going to create a new custom event that's going to be handling our movement down the spline. So, custom event, move on rail is what I'm going to call it. And we can call this here. And this is what we're going to be using to calculate our movement down the spline mesh. We'll take our grind rail variable, and we want to get our spline component again. So get spline. And we want to get location at distance along spline, with our distance being the distance variable that we just made. And we are also going to find rotation closest to world location. For our world location, that's going to be the location of our actor. So we can get actor location. And we'll just plug that in for right now. And we're going to change both of these local spaces to world spaces. We're going to drag over and set actor location. So what you'll see here, though, is that when we have our actor collide with the spline mesh, the location that it sets it to is the midpoint. We could add some distance underneath our actor, like subtract the location by like 80. That way it makes it look like we're on the feet. But we're going to still have the same problem with our rotation. So what we're going to end up doing is setting a relative location for our mesh. That way we offset this, and that's going to help us with our rotation as well, because the rotation's also going to rotate from that center point. So we can just drag off of our execute pin and set relative location of our mesh specifically. And we could just do relative of 15, I think is going to be good enough. There we go. But we still kind of have an issue with now after we attach our cameras not going to be in focus. So we're also going to set the relative location of our camera boom. And because it's not necessarily the same, we're just going to add 100 just so it could be up a little bit higher. Excellent. So now that's us getting on the rail. Now we want to move down the rail. And the way that we're going to handle that is by creating another trace timer. I'm going to go and make it right below this one. We can have a custom event. We're going to call it grind start. And it is going to be another timer. So set timer by event. And we can create a custom event. Call it something like calculate distance or calc distance. And we're going to take our distance variable and we're going to set it here. And what we're going to set it to is going to be our current distance along the spline plus a certain amount of distance that we want to move. And again, add node here, connect these two. And we want to change our timer to 0.001 as well and go to looping. And this is something we could say, try 40. And then after that gets set, we are going to get a branch. And this branch is going to be dependent on whether or not we are on the spline. If we are still on the spline, we are going to call our event to move on the rail. So move on rail. And if we are no longer on the spline at any point, we can just clear this timer automatically. And because we don't really need to set this timer as an event, we're just going to place it like that. And now, so we can call our move on rail here. And now that we made this grind start, we're going to go at the end of our trace. And we're going to say the move on rail. We can just do the grind start here. Now we are moving down our spline. Somewhat fast, so I'm actually going to change this 40 to 4. Okay, and then I'm going to turn off the traces so then it looks normal. Try that one more time. Okay, let's get our animation set up. The animation that we're going to be using, I named Wire Idle. It's a Mixamo animation that belongs to one of the ninja characters on Mixamo, but I think that this is a good enough pose to have on our grind rail to make it look like the character is actually bouncing on it. So we're going to go in our third person character, and we are going to open up Manny. And this is casting the character, so we just want to cast to BP underscore third person character, and we can change that to a pure cast. Our object is get player character. And then dragging off here, we can get on spline, promote that to a variable. And we're going to just add a fourth sequence node here. Compile it, and then we want to go to our anim graph. I don't know if this is going to mess with the control rig, so I'm just going to disconnect it for right now. And in our locomotion idle, we are going to blend poses by bool. And our value is going to be on the spline. So we are going to use our idle if we are not on the spline, so that's going to be our false pin. And the true pose is going to be our wire idle. Okay, now this is looking like something. If you get that error, it's only because we didn't do a validated get. You would want to set something up like this using your third person character rather than calling character, but I will let you do that for your own project if you like. So now we want to set the actor's rotation. And we're simply just going to plug in our node here for the closest world location. And this is a matter of personal preference. You could use the actor's location, or you can use a distance a little bit further ahead. That way it gives your character a nice lean into curves. We just get the actor's forward vector. Then we multiply it by a small amount, maybe 25 to 50. And then just add it to the actor's location. And use that instead. Now that's going to be a matter of personal preference. Maybe you have a mesh that's a bit bigger or a bit smaller, and that's going to look unnatural. Just play around with it and see what looks good to you. We're going to have our character automatically jump, and we're going to create a custom event. And we're going to call this rail jump. So when we initiate this, the first thing we want to do is set our movement mode back to walking. So we can get our character movement, set movement mode. Change that back to walking. If we are jumping, we're going to be going off the spline, so we want to change that variable here. And then we want to be able to launch our character. So we can get our actor's forward vector. And we'll split this because we only want to have a X and Y that is multiplied, and we'll have a static value for Z. We will drag off and launch character. And we could just... Actually, I'm going to recombine these pins, and then I'm going to multiply this. We'll change left pin to a float, and then we'll split this pin, just so I can cut down on the number of nodes that I use. And we'll split the launch velocity. Connect X, connect Y. Oh, I guess we have to put this back to a float again. And we'll say something like 1500. And for our launch velocity, we will do 600. So we'll go back to our move on rail, and at the very end here, we are going to make a new sphere trace. Set the channel to rail. And we're going to copy our actor location forward vector. And that's going to be the start and end, and we can have a radius of 25. Then we're going to get a branch. And how this is going to go is if we do the sphere trace and we miss, we've reached the end of the rail, so we want to do a rail jump. And you'll see we do jump at the end, however, we still need to change our offset. Moreover, if we want to jump off at any time before we get to the end, we need to also add our rail jump to the end of our jump. So we're just going to go and take our jump and our start trace, and we're going to put a branch between that and started. So we're going to take our spline Boolean, and if we are not on the spline, then we want to do our jump and our start trace, and if we are, we want to do our rail jump. Now I'm going to tighten that up a bit to straighten it out, and then we want to go up to our rail jump, and we're going to set another timer. And the event that we make is just going to be a custom event. And we can just call this reset offset. Because if we just do the set relative location, again, it's going to snap and look very janky to the player. So we're going to get our set relative location for our mesh. Then we can copy this node, and we are going to do the same thing for our camera boom. And we want to make use of the vinterp to constant node. We're going to connect these to the two locations. And for our camera boom, we are going to take our camera boom here, and we are going to get the relative location. That's going to be current, and we're going to reset that to 0, 0, 0. Next, we're going to do the same thing with the mesh. Drag in our mesh and get relative location. And for some reason, by default, the mesh is not set to be at 0, 0, 0. If you look at your mesh component for the location, it's at negative 89 for Z and 0, 0 for X and Y. Again, that's probably because at the center of our mannequin, that's where we're attaching and rotating ourselves from. So that will set it back to its normal position. The delta time, we can have it be relatively fast, 0.005, with an interp speed of 0.25. You can adjust these values as you like. So we'll compile that and save it. And we can just get a delay here for 1 second. So after we get to our target location, it doesn't really matter if this is running anymore. You can adjust this time if you'd like, but we're going to clear and invalidate timer by handle, not at the end of the timer execution, but after this delay. And if we are jumping off, because our jump isn't the normal jump and won't immediately go into doing another trace, we can just, after this timer, give a small delay of just 0.02 seconds or 0.2 seconds, and then we can do a start trace again. That way, if we press space, the delay prevents us from automatically reattaching onto the spline mesh. If you're going up a ramp and then you try to jump and then you collide with it and then you start going down, then it does the trace. You don't get enough time to actually, jump off of the spline point. And just double checking my math here. The location of the mesh. Target. Oh, we have to change our timer. Again, 0.00 and go to looping. Otherwise, it's only just going to fire off once. So now we're going to test out what we did. Our movement is a bit slow, so I'm going to increase that. We change this from 4 to, say, 10, so we're 2.5 times faster. Okay, and now we can go through and start designing our spline. So then we add rotations to it, maybe do a loop, and jump from one rail to another. So now we start the task of making our grind rails. I've been just using this straight pipe, but I'm going to duplicate this 2 times. For the left one, I'm going to add a couple points and make it zigzag. And for the third, we're going to make a loop. Now, as far as the loop goes, we have to click on these points and rotate these arrows so they're pointing inwards. This is basically where our character is going to be facing when we do the loop. If we just leave them as normal, they're going to go and just stay on top of the rail and go right through it. It's going to look very weird. And when making a loop, it's advisable to have as many points as possible for the smoothest transition. So we had our jump automatically run when we were done with our grind rail. So we could see that that works, hopping from one to the other. If we do our loop, see the character stays right side up. And with a serpentine style like this, we just rotate these arrows just a tiny bit. Give our character a lean. That's pretty much just how that works. Now, I want to go over just a few limitations here, just so then you're aware. At the end of our meshes, if we drag this out a little further before the mesh gets fully set, this will cause an issue with our spline trace down the line. And if we go on a spline with a broken end, it will end prematurely. So make sure the ends of your splines are perfectly flush. If you're having an issue with your meshes not lining up with the spline line, open up the mesh that you're using and drag it into your level. Change selection mode to modeling. Click on X-Form and select Edit Pivot and click Center. Note this error and click Accept. And now you can see the mesh has perfectly followed the line and no longer have any breaks. If it looks like your camera is shuddering when you're rotating around the spline points, especially during loops, you can go to your camera boom and change your rotation from relative to world. That way you'll have a smoother transition across the spline points. Since the way we move is by setting our location, we're not actually checking for any objects in the way. So if we're on a spline, we were able to go through objects as if they didn't have any collision at all. So that's how you can make a grind rail in Unreal Engine. There's still a lot more that could be done, but this should be enough to get you started, and if this video does well, we'll continue it with a part 2. So if you like the video, let me know by liking the video, and subscribe to see more tutorials in the future. You can also download all my work as a standalone Blueprint component by subscribing to my Patreon. So thank you for watching, and I hope you've been inspired.